Hello, developers. My team and I have been working on a new framework called Opus for Kotlin Multi-Platform. Opus lets you add video editing capabilities to your Kotlin applications. Now, Opus is going to be open source, but we're still tidying things up a little bit before we're ready to release it. And since the Kotlin conference is coming up in a few days, I'm making this video to give you a little sneak peek into what Opus is and how you can use it. Now, I'm going to start by talking a little bit about who I am and about Prismatic, the company that I work for, but you will see some coding towards the end of the video. So my name is Matt Feinberg. I'm CTO with the Prismatic company. We're a fairly new startup, but you might be familiar with some of the older projects I've worked on at past companies, such as KineMaster, which was the first video editor for Android, and Alight Motion, which was the first motion graphics application for smartphones. Now at the Prismatic company, I'm working on a number of commercial products under the Lightweave brand, and these are all about making intelligent content accessible to everyone. So intelligent content is content that adapts to the use case. So let's say I make a YouTube video, but then later on I automatically want to have an Instagram story as well, or a blog post based on the same content. And if I make updates or changes to that content, I want those changes to be reflected every place that it's used. As you might imagine, this is something that's fairly new and challenging. No one's quite done something like this before. So we came to this knowing that we were going to have to iterate and make changes because we don't expect to get it right the first time. So that means we need to have a very solid stack underlying this technology. And well, that is Kotlin Multi-Platform and Opus. So what is Opus? Opus is a video timeline composition framework. Basically what it means is you can do video editing, audio editing, you can combine different videos and composite them in different ways, create visual effects, do animation, motion graphics, and a whole lot more. So it's not just, you can use it to make something like iMovie or KineMaster, video editing or motion graphics application, but many other kinds of applications could also benefit from having video capabilities in them. So for example, if you were making a game, the achievements in the game, you might want to make it possible so that your users can share those on social media. And a lot of games or apps will let you share your achievement by giving you an image you can share. But what if you could share a video instead? If it was very easy to add that kind of functionality to your application, that could be very interesting. Or for example, you could build an IDE plugin that takes your edit history and turns it into a watch me code time-lapse video. So there's a lot of things when adding video capability becomes easy, there's a lot of things that you can do with it. So how does Opus work? Well, Opus works by taking a number of inputs. So you could have different types of layers, like video layers, image layers. You can have audio tracks. You can do custom rendering and all kinds of things like that. And those are combined into a composable multimedia timeline. And from there, you can display a preview of that on the screen in your Compose user interface. You could render that and export it to an MP4 file, let's say, in different encodings, to an audio file if you want to share that as a podcast. And Opus also provides a number of additional features. For example, you can capture thumbnails either from the composed timeline or from your original source media. So it's an easy way to make video thumbnails. You can retrieve metadata, for example, duration, frame rate, encoding, other things like that from your media in a platform-independent fashion. And all of this is done in a way that should be familiar to you if you've used Kotlin, and especially if you've used Jetpack Compose or Compose Multi-Platform. So for example, the composable multimedia timeline itself is just a series of composable functions, just like you'd use in the UI. The difference is that instead of columns and rows, you have tracks which lay out their children sequentially in time, or groups which lay out their children concurrently, simultaneously in time. And all of that is driven from state, just like Compose UI. So if you have a remember mutable state of or something like that that you're using for your UI, you can use that same state in your video timeline and it will update and recompose automatically in real time as you make edits. And everything else that you see also falls into that same kind of framework. So for example, if you want to play that composable timeline, you would get Opus Player with a remember Opus Player call. This is something you should be familiar with if you use Compose UI. You can use an Opus View to display that preview in your app's UI, and that is just a composable function, just like anything else that you would use, like a button or a slider. So Opus is currently supported on iPhone, iPad, and macOS, and Android and Windows are in various stages of development, but making very good progress on those. And web and backend support are coming soon. So if you have a WebAssembler project, you'll be able to use Opus with that and render in browser. And Opus will be open source. We're just tidying things up a little bit before we're ready to release it. So without further ado, let's look at some code.
All right, let's get started. I have here the standard Compose multi-platform template that I've downloaded from the wizard. I have made 3 changes to it. I changed the default location of the window so that it's easier to do screen recording, and I added the Opus dependencies, which are going to change anyway when we release that as open source, so I'm not going to show you how to do that this time. And I added something in the desktop specific code when the window is created to make it possible to add Opus views into the desktop window. None of those are super critical to understand, so I'm just going to skip that and get to the interesting part. So to begin with, the first thing we have to do is make sure that we're providing an Opus environment. So we need to wrap everything in provide Opus environment. There's a lot of things you can do with Provido's Opus environment, including controlling debug logging, changing how external media is loaded, and all kinds of things. We don't need to change any of that now, but there are settings available there. Okay, so let's get rid of the boilerplate from the template. And the first thing we need is to create an Opus composition. So we do that using remember Opus composition. And inside of here, actually, let me just paste in some video files that I already prepared that we can use for this. And yeah, inside the Opus, remember Opus composition, you use composable functions just like for Compose UI. They're just a different set of functions. So instead of using, for example, column and row to lay things out vertically and horizontally, instead you would use group or track. A group will time things concurrently, and track times things sequentially, one after the other. And then inside of a track, let's just put some videos. So I'll start with a water ripple video, and then we'll do the cherry blossoms video. So now I have a video timeline with the water ripple video playing first, followed by the cherry blossoms video. Now, in order to play this back, I need something more. I need a player, and we do that with remember Opus player. Now, the reason this is a separate thing from the composition is you might not want a player. You might want to export it instead, or do both at once, or have 2 players showing the same composition at different times. And so you can do all of that. Now, if I were to call player.play right now, we would just see, we would not see anything. We would only hear audio if there was audio in those videos. So instead, we need to create something in the Compose UI to show the output of that player, the preview. So for that, we use Opus View. And we'll just pass the player to the Opus View. And I'm going to do a little bit of layout stuff here just to make sure that we can see this properly when we run it. And the only missing piece now is we need some way for the user to get the player playing. So we need a play button. So I'll just do an ordinary compose button. And in here, I will put the text and we'll just call it, we'll just say play. Great. And then, of course, for on click, we'll just call player.play. Let's try it out. So here we go, it's playing the video. One of the things you'll notice, however, is we have no way of stopping it. Okay, there we go. We went on to the second video. Great, everything is working as we expect. But of course, it would be nice if we could stop the video playing. So let's do that. Instead of having just play here, let's check the player status, and we'll go in here and say if player.playing. So player.playing is backed by state. So we can use that for all kinds of things, and that in Compose UI it will recompose automatically if necessary. But for here, if it's playing, we'll just tell it to stop. And if it's not playing, we'll have it play. Of course, we don't want a stop button that's labeled play. So instead, we'll say if a player is playing, we're going to call this stop. Otherwise, we'll call it play. And let's try that out. Excellent. We now have a stop button. I can play and I can stop. Of course, we want more. I want to be able to seek the video and see what the current playhead time is. And of course, all of those things are exposed as state from the player. So I could get the playhead position, for example. Let's just do that here real quick. We'll do player playhead, and we'll have that format as seconds and frames, let's say. We'll give that frame rate of 30 frames per second. And we'll just say playhead. And if I now run this, because the player properties are, as I said, state, if I click play, you can see the time is now going up here. If I click stop, it stops going up. Great. You can build your own controls, whatever you want to do, but I want to focus more on the features of Opus and what you can build into the video timeline, into the composition. So instead, I'm going to get rid of all of this, and we have, for convenience, something called Opus Player Controls, and I can just give that player, and you can look inside this if you want to see how it works. If you're building your own, just take a look under the hood inside of Opus Player Controls at the code. So here we now have a play button that changes to pause. We have a seek bar I can drag around. The current time is shown over here on the left, and the total time is shown over here on the right. So now we can move on to some more interesting things. Okay, so up here, where we have our composition, there's a lot of other things that we can do with this. To start with, let's try changing this from a track to a group and see what happens. Remember I said groups are timed concurrently and tracks are timed sequentially. So we're now going to be seeing both videos at once, but of course, what is that going to look like? Well, one's going to be in front of the other one, and actually we just see one video because one is covering the other. So we can make the one in front smaller. So just like Compose UI has modifiers, we have operators. They're basically the same thing as modifiers. We just needed a different name for them because you use Compose UI and Opus together quite frequently. We didn't want to have something also called modifier that would be confusing. So we have operator, and I can say, let's scale this to 50%. And now we can see both at once. Now, there are a lot of other things that I can do with operators as well. We have ones like scale to fill. We have scale to fit. So if you have videos that don't happen to be the same size as the composition, you can use these to automatically scale them to the appropriate size. But let's go back to, let's try one more thing in here. I'm going to add a text layer on top of this. It's text visual. And I'll say, hello, Kotlin developers. Just a side note, it's called text visual, not text, because Compose already has text, and we wanted to avoid confusion again, because these are often used close together in the code. Okay, there we go. There is well, there's text there, but it's a little bit hard to see. Actually, I should remove the cherry blossoms video here. We don't need that right now. So we have text. It should be easier to see over the water ripple. Of course, just like text in Kotlin, you can in Compose, I should say, you can customize things like the font and so on. Text, so we have style here, which is an ordinary text style, just like used in Compose multi-platform. So this should be a very familiar API, very easy to use. We also can use operators with text as well. And let me do that now. Let's set the color to cyan. And we also, you'll notice that the text itself doesn't have any intrinsic duration to it. Video does. Video has a, it's a certain number of seconds or minutes long, but text doesn't. Well, because we're in a group with something that has an intrinsic duration, the text visual is automatically inheriting the duration of the group, whatever the longest thing in the group is. If we were in a track, we wouldn't see anything right now because it would have a 0 duration. So how do you change the duration of something? Well, same thing. Let me just move my operators here to separate lines. I put a duration in, and let's make this 3 seconds. So now if I run this, now you can see there's the text. And if I click play, after 3 seconds, the text disappears. Okay, next, let's try some other operators here. So we have the alpha operator. And so for this, I can use the alpha operator to make this partly transparent. Let's see how that looks. There we go. That's pretty straightforward. But there is a variant of the alpha operator that takes a lambda. And inside this lambda, we have access to the playhead time. So I can get the number of seconds that we've played so far as a floating point number. And let's just make sure that that's clamped to the 0 to 1 range. So after 1 second, it will just stop increasing. And so now I'm calculating the alpha based on the playhead time, which means I've created an animation. There we go. There are a lot of other things that I can do here. For example, let's say, so we have some convenience functions we can use here because doing all the math yourself every time, plus you probably want easing, is going to be annoying. So we have animate in, which has a default duration. Now if I run this, we will see that it fades in. at the beginning. And if I want to, I can also multiply that with animate out. And let's give animate out a let's make that a longer duration. So make it 2 seconds for animate out, and we'll make it half a second for animate in. And now if we run this, there we go. We can see it fades in and it fades out. This applies to all kinds of things that we can use as operators. But let me move on now and show you how we apply other types of effects here. So I have this group. Before this group, let me add a video. Actually, let me wrap this in a track. Then in this before the group, we'll have another video, and we'll use the cherry blossoms for that video. And that's a bit of a long video. I don't want to wait for it to play. So let me set a duration here of just 4, I'll make it 3 seconds on the cherry blossoms video. So now if I play this, you can see here's the cherry blossoms video, and then we have that plays for 3 seconds, and then we have this group with the animated text in it. Well, let's say I want to transition between them. Okay, easy. I'll do a crossfade transition, insert that there, and now if I run this again, now one will crossfade into the other one. So I have a crossfade between this single video and the group. Of course, I can specify a different duration for the crossfade. I can do other transitions as well if I want to. There's a lot of rich functionality there. But let me show you how we can apply filters now. So there's a couple of ways I can do this. One way, so let me just swap these around. I'm going to put the water ripple up here and the cherry blossoms down here. I'm just going to show you what that looks like now, and then I'll make some changes. The reason for that is that the filters I want to use are going to be a little bit easier to see on the cherry blossoms. So there we have, this is fading into the cherry blossoms, and there we have the text. Let me just make that text longer, because that's going to matter. Let's make it 6 seconds long. Okay, so I'm going to add and apply filter composable here. Oh, sorry, wrong. Yeah, no, that's right. I'm going to add an apply filter composable here. The apply filter composable function is like an adjustment layer. It applies to everything underneath it. So let me do a wave warp filter. And the wave warp filter, let's make the angle 45 degrees. The interval, we'll leave that at 10, and I'll just make the strength, say 50. And let's see what that looks like. Well, there we go. That's a bit crazy looking, but that is the wave warp filter applied. When I'm using apply filter, I can actually make that work with, so let's make this a little bit less crazy. Let's make that a 30, and let's make the interval, say, 5. Then what I'll do with the angle is I'll make the angle based on the playhead time. 2 seconds as a float times, let's say, 45 degrees. So now we're going to animate the angle used in the filter. There it is. You can see that warp is sort of spinning around. Now it looks really weird. Okay, that's kind of dizzying. Maybe not so great. But the important point is that this apply filter is like an adjustment layer. It affects everything underneath it. So if I move it down to after the text visual, we'll now see that it is also warping the text. Okay, let's make that interval like 25, something like that. That should be a little bit less annoying to look at. And so, of course, there's going to be times when you want to apply a filter to one thing, not everything underneath it in the composition. And so there is, of course, a way to do that. Let me just grab this wave warp filter code here and get rid of the apply filter function call. And instead, let's do this as an operator. There is an apply filter operator. I can put the same filter in here, and now it will affect only the thing that it is applied to. There we go. And it is only affecting the background. Well, that's what it was doing before. So let's move this to the text visual, and we'll see that now we're going to be able to warp the text without affecting the video. And there it is. The text is warped. So there's a couple of other things that I want to show you here. One of them, let me just sort of simplify this down to, let's get rid of all of this. Let's simplify it down to a group, image, visual, and then we'll use the stars image, and we'll give that a duration of, let's say, 10 seconds. So the reason I'm using an image here, this works just fine with video as well, but there's motion in the video, and I'm going to be doing some animation, and it's just going to make it look a little bit confusing. So here we go. There's our test image. And what I'm going to do with this now is I'm going to offset this. And let's make the offset, let's say, minus 100 and 0. And now there's a third coordinate here, which is the z-axis. Let's make that one minus 1,000. Okay, so let's try that. And what we're going to see is it's, well, just smaller because it's further away. But is this really 3D? Well, spoiler, yes it is. Let's move all of these to separate lines, and then I will duplicate that. So the one in back here, let's apply a filter. We'll make this just saturation 0. And brightness 0.9. This is just so that we can tell it apart from the one in front. And then, well, it's not in front yet. Let's put that at minus 600. And we'll put that at positive 100 for its location. So let's take a look at this now. Okay, we have two images now. One's in front of the other, but how do we know it's really in front of the other? Well, let's make a camera. You can put cameras anywhere you want. If you put them in a group or in a track, you can have them affect only a particular part of the timeline, so you can switch camera angles. But for this, I'm just going to do a very simple one. Let's have the camera offset be, so this is going to be a lambda version of the function, and it has to return a vector, which will have x, y, and z offsets in it. So this allows us, because it's the lambda version, we can calculate based on the playhead time. So let's do that. Let's get the playhead time, and let's get that in seconds as a float. And actually, let's take all of that, and we'll just take the sine of it, because the sine function repeats, and then we'll multiply that by, let's say, 300. So what this is going to do is it's going to make our camera move left and right over time. And of course, if things at different distances, when you start moving left and right, you get parallax motion. And we can do some other things with this, of course. See, this is the Z coordinate, so we'll do animate in, and we'll make this over 3 seconds, and we're going to multiply that by, let's say, minus. No, let's make it 1,000. That's going to be should be a reasonably significant zoom. Let's try that. Oh, of course, I have it the other way. I'm having it move away from that, because what we really want to do is to say 1,000 minus that, and then we'll be moving forward into it. So here we are. We have a camera zooming in and moving left and right at the same time. Now, what else can we do? Let's take that front image and let's rotate it. So, of course, I can do a simple thing like let's rotate it 20 degrees. This will put it at a 20-degree angle. Yeah, like you'd expect. Okay, great. But we can also rotate around the y-axis, which will give us a sort of a 3D effect. We'll make that 45 degrees around the y-axis. And so you can see here, we're now looking at this at an angle because we've rotated it in 3 dimensions. Okay, there is so much more that I can show you about Opus, but what I'd like to do now is show you how you can use state from Compose UI to modify the Opus composition. So let's build a simple video editor. Okay, it's going to be super simple, but that's fine. So we're going to start by having, let's say, user selected videos. And this will be a mutable state of, it's going to be empty, so we put the type here. This will be a list of video sources. Then let's come in here and we'll add underneath the player controls, I'll put a little spacer there. And then let's put a row here and arrangement. Go. Just get this spaced by. Let's make that 5. Okay, so let's put some buttons in here. I will. Let's call this one water ripple, and it's just going to add the water ripple to the list of user selected videos. And let's just do the same thing for the art wall. So there we go, art wall. And call it art wall. And the cherry blossoms. Okay, so now we've got 3 buttons. The user can click them, and clicking them will add video sources into this list. And so we can then do something that depends on that state. So we'll make a track. And inside the track, let's do, let's say, user selected videos for each. And we could do video. Oops. We can do video of that source. Okay, that's pretty straightforward. I forgot to All right, so okay, here we go. As you can see, we just have a blank screen because there's nothing in here yet. If I click cherry blossoms, there's the cherry blossoms video. Now if I click, you can see my total time is 25 seconds. That's a longer video. Let me click art wall. Now it jumped to 40 seconds because at the end here, now we've got, there it is, the art wall. If I click water ripple, there's a water ripple at the end. And I can say, okay, let's do another cherry blossoms, another water ripple. And there we go. So you can see here that we are now able to make edits in the video. Let's do a different kind of edits instead. Yeah, like making a track. I will do a group. And inside the group, we'll do a solid color visual in, let's say, blue. And then we'll do a text visual, and we'll make this say hello, and we'll make this in cyan. Okay, and we need durations on these, so duration, let's make this 3 seconds, and we'll do the same thing here. Oops. I have the order of those wrong. There we go. Okay. So now we have a group with some text and some other stuff in it. And then I'll just put another text visual down here after this. Actually, let's make that 5 seconds. Make that 5 seconds. I'll just make this 3 seconds, and this will be the end. And we'll make this yellow, and let's put a crossfade transition between them. So let's just see what we have so far. Oh, of course, I didn't get rid of this. Let's get rid of that. So there we go. We have the text and the solid color background, and it crossfades into the end. Okay, great. Super easy. Let's say that we want to change something about that. Let's say we want to make the size adjustable even. So let's do that. Let's come in here, and I'm just going to add a slider, and we'll just have this be something like text size. Yeah, let's just make that 10, and we'll make this slider, so the text size, and we just need a value range will be from, let's say, 4 point to 200 point text, let's say. Okay, so we've got the slider. Now we can adjust the text size, and we just need to use that somewhere. So let's do that here. We'll say font size. That needs to be in SP, of course. Let me put those on separate lines. It's easier to see. So yeah, we have 5 second duration, and the text size is now coming from that slider. So there we go. I can now, here's my video, and this slider down here controls the text size. So you can see that this basically allows me to enable the user to actually make changes and edit video this way. Okay, the last thing I want to show you is how we would export this. So to do that, we already have a player. We would just need an exporter, and that's, remember, Opus Exporter. Very easy. And the one other thing that we need is we need a coroutine scope for this, because the export happens in a coroutine. So we have structured concurrency. If we if this leaves the composition, the export will be canceled automatically, and so on. So it's quite easy to work with. And then we just need to, let's get rid of this slider, and instead let's just add a button, and we'll have the click there, and we'll call this button export. And well, how we would do that is we would just in the export scope, we would launch, and then we just call exporter export video. Now, one of the things about the exporter is it does have two required arguments. One is some settings, which I'll explain in a moment, and the other one is the output path. So we can use the same output path that we were using here, that I had my sample video in. I'll just call this export example MP4. Okay, great. So what goes into the settings? So this is a DSL. There are default settings for everything. But for example, I can come in here and I can say, okay, I want my video to be HEVC, and I want the resolution of the video to be, let's say 1080p for my video export resolution, and let's say I want my audio to be AAC, and I want my audio sample rate, let's say to be 44.1 kilohertz. So this is how you would set that up. Now the only problem, of course, here is that we don't have a way of canceling the export. So that is easy. There's two ways you can do it. You can just cancel the coroutine, so I could just launch this in a job, or what we recommend is using the property exposed by exporter. So what I can do here in the onClick event is I can say if exporter is exporting, then let's cancel the export. Otherwise, let's do all of this. And I'll just add braces to that. Okay, so if we're exporting, we're going to cancel it. And if we're not exporting, we're going to start this export. But okay, now our button says export. So just like we had before with the play and pause, we want to say if the exporter is exporting, then we want to label this cancel. Otherwise, we want to label it export. And the other missing piece here is we really ought to have a progress bar for this. So let's do a linear progress indicator, and we'll just give it exporter progress. Great. And then let's just give it a little bit of, let's see, padding. And there we go. And of course, you could control the visibility based on, if you wanted to, you can control the visibility based on whether it's exporting, so the progress bar only appears during export. But here we go. Click export, and it's now exporting. So just a couple more things that I want to show you. The first one here is, let's just go back to, let's have a group here, and we'll put a video in with the cherry blossoms. And let's say that I want to render something on top of that. There is a canvas visual, and this gives me a normal draw scope. So for example, I could just say draw circle, and we'll make that green. And then I could take this, and well, let's run that and see what we get. So there it is. We have a green circle on top of the cherry blossom video. And of course, if I wanted to, I can do things here like I could animate scale or animate opacity. All of those things are available. Okay, so as you can see, there is a lot that you can do with Opus. But this video is getting long enough, and I have barely scratched the surface. So what I want to do instead is just show you how the Opus composable functions that we've been using are implemented. Because there is a lower level public API that these are all built on top of. So for example, if I look inside of video, for example, this is using Entity, which is a very low level primitive. This is a way of just placing a single item into the composition for timing purposes. And Entity automatically gets its timing from an operator, so we're just passing that operator on. But because video has an intrinsic duration, we want to know what that is, and we want to provide that as a default if the operator hasn't specified one. So Here we have another API that we provide, which is remember media source duration. This will go ahead and parse, if necessary, that video file, find out how long it is, and this runs asynchronously. So this media duration is state, and it will change as it's loading. But obviously, we don't want to start playback before it's finished loading. We don't want to export a video that hasn't finished. So if you look inside this remember media source duration and you go far enough down, here we have a launched effect to actually call our metadata reader API and get the information about the video. And so while that's running, we have an unknown media duration. So what do? We call this special Opus loading function. As long as this is in the composition, it means we're not ready to start playback. Once all of these have left the composition, then Opus will begin playback. And similarly here, if we have an error loading that, we're calling the Opus error composable function. When there's an Opus error in composition, there is a errors property exposed on Opus Player that allows you, the application can then base UI decisions off of. So for example, that can tell us which part of the timeline had the error, and so you could then go in and say, okay, we have a missing file here. Maybe the user put a video file in the timeline and deleted it later. So let's go back to video here. Inside of the entity, so the stuff that's outside of the entity here, this is going to happen regardless. This will happen even before the playhead has reached that location. We need to know the times in advance for timing purposes. But the stuff that's inside here, this can happen. This is deferred until we actually need it. So inside here, we have this remember media decoder. This basically is creating a media decoder that's going to decode the video. And we've told it that we want the texture from that video and we want it to play the audio. So that means, because we've set provide texture to true, that this decoder can be used as a texture when doing GPU rendering. And here we have our low-level primitive called visual render that allows us to actually render directly using the GPU. And so inside this onRender block, we have the ability to call our sort of high-level API for doing graphics rendering, which then in turn calls the appropriate APIs on the platform. So here we're doing just very simply high-level API draw quad with this texture. But for example, if I go back to here, and let's take a look at the canvas visual instead. Canvas visual, here, it's much simpler. It also has an entity the same way. This one is remembering a drawn texture, and we're just giving it the draw scope block. Well, you can draw whatever you want in here. You can use this directly if you want a different lifetime or something for the texture that you create with it. And then in visual render, we're drawing a quad using that texture. A few other things. Let's say, for example, that we wanted to, let me add a text visual here. Hello again. And let's make this green. And I'm going to associate an ID with it. Now, you can use any identifier that you want. This just takes in any parameter. Normally, we would recommend that you use something other than a string, but this is just for demonstration purposes. Now, let's say that I want to be able to detect clicks on this. I just made the ID so that we can do click detection. Well, the normal way you would detect clicks, of course, would be here's the Opus view. It would be to use pointer input, right? But we want to know where the click was in relation to the things in the composition. So instead, I can use Opus pointer input, and this works just the same way as regular pointer input, except that I'll put detect tap gestures in here, except that, okay, I have here the offset So tap location. Okay. What I can do here is I can now call hit test. This is an extended API on top of the normal pointer input one. Then that will give me the ID of the thing that was tapped. And so now we need a place to display that. So under the player controls here, I'll just put a text, last click, and last click info. And of course I need to define this. So let's come up here and I'll do last click info by remember, mutable state of, and we'll just make that a string. And yeah, now what I can do is I can just call toString on this or none, none, and let's just assign that to last click info. So now if I run this, and if it all works, there's my text, and when I click here, I'm getting none. If I click on the text, it says green text. And so you can see there is also a way of handling pointer input with relation to the things that appear in the video. In addition to that, I think this is the last thing that I will show you. Let's say that we have an apply filter here, and let's say it's the wave warp filter. Let's take a look at the wave warp filter itself, because this is also written using a lower level public API. And so here's the wave warp filter. And the important thing, if you look far enough down, is this remember warp shader. This is a convenience wrapper on top of a more general remember shader function. But basically, inside of here, this is ordinary GLSL code. And it is compatible with WebGL. So basically, you can write shader code in here, and it will work on any platform that Opus supports. And you can see we have a DSL up here for defining uniforms. And down here, I'm calling draw mesh, and I'm giving it the shader and the uniforms that I want to pass in. And so the only thing that's really different between this and an ordinary composable function is that the filter instance is provided via this filter properties call. So that allows us to handle this all at render time, and therefore it can be animated because it happens when we're actually rendering that particular frame. Okay, so as you can see, Opus has quite a rich feature set, and we are preparing to release this as open source in the near future. In the meantime, if you have thoughts or feedback, please get in touch. In particular, we're interested to hear if you have use cases for Opus, because that will help us to prioritize features that we are adding into the Opus framework. I will be at the Kotlin conference this coming week in Copenhagen. If you happen to be there, get in touch. I'm happy to chat about Opus. Yeah, please please get in touch and let us know what you think, and if there's anything more that you'd like to see from Opus. Thanks, and let's go make some amazing apps.